All right, we're on the 2.6 ready homework from the Mathematics Vision Project. Please make sure at the top you've written your name and your period number and today's date. So the top section is multiplying, getting us ready for numbers 5, 6, 7, and 8, because there we're supposed to factor or unmultiply. So let's go take a peek and see if doing the top section helps us in understanding the next section. So here I'm just going, let's distribute the x times 4x, and then x times negative 7. 5x times 3x is really just saying the coefficients multiply, 5 times 3, and then x times x, and then 5x times 8, and finally 3 times 3 is 9, x times x is x squared, 3x times negative 2. So when I distribute that initial value, it gives me a true two-term expression when I'm done. And this is now written in standard form, ax squared plus bx plus c. Notice there are just no c values. The answers to problems 1, 2, and 3 are quadratics that can be represented in standard form, which coefficient equals 0 for all of the exercises above. So c equals 0, meaning there's nothing here at the back in each. Now, on the next ones, write the expressions as a product of two linear factors. Here's where we're being asked to go backwards. Now, if I stretched each of these terms out, this is one way that some of the math teachers teach here. X squared could be written as x times x. 4x could be written as 4 times x. And you're looking for what's in common to go out front. And then you're going to say whatever's left over, x plus 4, goes inside the parentheses. So one way to do this is to stretch out each term to see what's in common. But a lot of you can just look at this as these both could be divided by x. Like, what can divide into both? So since an x is in both of them, x becomes my greatest common factor. And then I think x times what would give me x squared? You got it. There's a plus in the middle. And then x times what would give me 4x. To double check that I've chosen the correct two expressions, I'd say x times x is x squared, x times 4 is 4x, and that's how I check my work. Okay, pause the video, try the next one, see how you did. So here, an 7 can divide in, and an x can divide into both. But if you don't see that, then let's stretch out and see what's in common. For example, 7x squared could be stretched out as 7 times x times x. 21x could be stretched out as 7 times 3 times x. Then I notice that there's a 7 in common and one x in common, so that 7x is my greatest common factor. Then what's left over? There's one x here, a minus in the middle, and a 3 right here. And then I double check myself by multiplying. 7x times x, yep. 7x times negative 3, yep. Think I've factored it correctly. All right, what goes into 12 and 60? Let's break this down. 12 could really be 2 times 6 or 2 times 2 times 3. And then there's x times x. 60 is 2 times 30. 30 is 3 times 10. 10 is 5 times 2. Then there's an x. So what's in common here? I see there's a 2 and a 2. I see there's another 2 and another 2. So 2 times 2 is 4. And I see there's one x in common in both. So those things that are in common, the 2 and the 2 and the x, those all multiply to go out in front as my greatest common factor. It means a 4 could have divided into both and an x could have divided into both. Then to get my back two terms, I see what's left over. There's a 3 and an x, and 3 times 5, which is 15. To double check that I have chosen the correct expressions, I would want to multiply this and make sure it gives me my original. 4x times 3x, yep. 4x times 15, yep. This should be factored correctly. There it is. Okay, try to pause the video and try number 8 on your own. All right, 8 is 4 times 2. 20 is 4 times 5. What's in common? a 4 and an x. So that goes out front. What's left inside? And then I multiply to double check. 8x squared plus 20x looks good. All right, the next ones are using the box or the FOIL method, your choice, multiplying binomials. And you should come up with x squared minus 81. Please show the full work there to get the positive 9x and the minus 9x, showing how they cross out. These are just answers. You need to show your work to get credit. The answers to these problems are quadratics that can be represented in standard form. Which coefficient A, B, or C is 0 for all? So this time, the middle term crossed out each time because of one positive and one negative. So B is equal to 0 in all of them. There's no B. Right, on these bottom ones, you can do this method. Hang on, let me use a straighter thing. If you want, but your job is to get the factors for each. So we tested multiplying above, now we're unmultiplying. Okay. So in the first one, 45 goes in the top and 14 goes in the bottom. 45 in the top, 18 in the bottom, 45 in the top, 46 in the bottom. So notice it's all the same C value, but different B values. So here we notice that 45 could be the 9 times 5 factors. So how do we write this? We write x plus 9, x plus 5. After you might be using the x just to show your work. This time 45 would be 3 times 15. This next one is just 1 times 45. How'd you do? All right, this one looks like 8 and 3. This one's 6 and 4. Uh, 2 and 12. Okay, here we've got a 6 times 6. Here we've got a 9 times 4. And 36 is 12 and 3. No, 18 and 2. We want a 20 on the bottom. Remember, it's okay to write your factors forwards or backwards. Doesn't matter which one goes first. All right, last row. Uh, 100 is 20 times 5. Let's put the larger factor on the left. And then to get negative 15, it needs to be negative there. Here is positive 120. So I think it's just 10 times 10. And that means I could technically write it as 10x plus 10 squared. And then for 29, it's 4 times 25. All right, are you getting good at those x's, at factoring?